one of the other categories you always hear about, and kind of what the emphasis of this event today is about, is energy in the atmosphere. And obviously the atmosphere is impacted by the amount of energy we're using, the source of that energy, the frequency of use, the intensity of use. Energy has proven to be a difficult topic, although a difficult topic to get people to rally around. And although it's one of the easiest metrics to understand, because everybody pays for energy and it's a direct correlation, how much energy you use to how much your operating expenses cost that month or that year, it's a technical kind of scenario, and it's also one of those things that a lot of people just rely on the energy always being on and always having it. And so that sort of nomenclature that goes along with understanding energy efficiency and building science is a challenge. And when the conversation gets lost in people who don't know that nomenclature, it's not as powerful as it could be. And so one of the things that the Department of Energy, and the Department of Energy has been focused on energy efficiency for a long time. They have a great program in the Energy Star program, the Energy Star Portfolio Manager. If anybody owns office buildings or leases a significant portion of an office building, I recommend that you get involved in their Portfolio Manager program just to understand how your building's consumption compares to all of the buildings around you. But to try and broaden their market, the DOE now has put out a glossary, a building science translator, which is a glossary, which basically allows everybody who's engaged in the built environment to better understand the technical side of things like heating, ventilation, and air conditioning, and to understand the connection between things that affect the energy efficiency of a building and their physical comfort, not just their cost at the plug load. So, again, when it comes to energy, this is kind of the direction we're trying to go in. We want to see more renewable energy. We want to see more solar power. We want to see more daylighting. We want to see more big overhung roofs. All these types of things, when you look at a property from the curb, when you see these types of images, these types of things going on, you can understand that that's value that's been added to those properties. So we do have challenges in South Florida when it comes to energy efficiency, and it comes to the energy side of that sustainability conversation. For one, Florida is the only area in the whole country that's considered climate zone 1A. And what that means is it gets really hot and it gets really humid. And so for us, in our buildings, when we're conditioning air, we're not just cooling the air, we're cooling and we're dehumidifying the air. So within that scenario lies a complicated challenge. How do we make the inside as comfortable as we want it to be, and still maintain a high quality of indoor air and indoor environment? So being in a hot, humid climate, that's one of our challenges. Having FP&L as a monopoly in the state, the only place we can buy our power from, is another challenge. Unfortunately, right now, FP&L is doing a lot of work with renewables, but they kind of have the whole industry in a chokehold and aren't letting it out into the public, so to speak. The other challenge is that we've been building buildings down here the same way for a really long time. And what's exciting, I think, as if you're involved in development or construction or design, or even engage in those trades, as a client, to push designers and to push developers to do better by sustainable design, to understand how changing the configuration of a wall can impact you and your comfort and the performance of the building. So, for us, it's about keeping the heat out and about keeping the moisture out, keeping the air inside cool. It's kind of our biggest challenge. So it really starts with the walls of the building. It starts with the insulation, how that insulation is installed. Don't be afraid if you're building houses or if you're designing houses to get down on the site, have someone get down on the site for you, inspect how that insulation is being installed, understanding what it means to be a grade 1, grade 2, or grade 3 level of insulation. So basically, if you have a grade 3 level of insulation that on any given wall in your house, and these walls are your perimeter exterior walls. It's what's keeping you cool and keeping the moisture out. A grade 3 level of insulation is going to allow for a significant percentage of gaps in that insulation and the way it's installed, whereas a grade 1 insulation is going to ensure that there's very few gaps anywhere around junction boxes, between the gypsum board and the different types of insulation that's being installed. You know, if you're on the design side of this, or even if you're just hiring someone to be on the design side of this, you know, ask these hard questions. Push the designers to be more innovative, to explain to you, to give it to you in layman terms. What does this mean? If I make this choice, if we have R30 insulation, if we install it one way versus another way, look at the details, understand the shop drawings, and ask the hard questions. Push them to make sure that your indoor environment that you're building and that you're living in is going to be free of moisture, and it's going to do as much as it can to keep the heat out. Windows is another big part of that conversation. For us in South Florida, the most important aspect of windows, and again, we're constantly trying to keep the heat out, get some natural daylighting in, and keep the moisture out. And so, you know, those walls full of insulation and the windows are kind of our first line of defense. For us here in South Florida, the most important performance characteristic about the windows is what's called your solar heat gain coefficient. And so the solar heat gain coefficient is the ability of the window to keep the heat out and let the light in. So obviously, the more light that we let into the space, the more you can use it as a natural daylight harvesting approach. The less you'll need to rely on electrical light, which oftentimes just generates a lot of heat inside the building as well, and also helps keep the heat out of the building. So at this point, most environmental rating systems, most green building rating systems really focus on a solar heat gain coefficient of windows that does not exceed 0.3. And so the lower, when it comes to solar heat gain coefficient, the lower the number, the better. So the lower the number you see, the less heat's coming into your house through your windows. And you're maximizing your ability to daylight, and you're maximizing your ability for your air conditioner to work less and still cool the space to the same degree. So, you know, ask the question, what's the solar heat gain coefficient of that window? Understand what that means to you and your ability to be comfortable where you live or work. Performance testing, this is another aspect of green building that's gained a lot of momentum, is very exciting. It's something that in my personal practice, in my business, it's something we've started to do recently, really to test all of the building scientists that promote green building. This is kind of the green building community's way of fact-checking themselves and seeing if what we're talking about is really working. Like I said, it's been, you know, over 15 years, but 15 years where the green building industry has really kind of had a spotlight on it, and that's created a tremendous data bank of building and building data. And so by doing things like using thermal imaging, by doing things like testing your ductwork, by doing things like blower door testing your whole home, whether it's a new construction project or an existing home, it will give you a tremendous amount of insight as far as how your building's performing and what's really happening inside the building. On a new construction project, blower door testing and duct height testing is a way of quality assurance. It's a way to convince yourself that the contractor and the subcontractors are doing everything that's in their scope of work, and that the building isn't going to have a lot of problems as soon as you try and get tenants in there or as soon as you try and occupy it. On existing buildings, it's a way to understand what's happening behind the walls, what's happening up in the areas of your house or office that you can't get to easily. So are your ducts leaking? How much leaking do you have? Is your envelope leaking? Where are you losing heat? Where are you gaining heat? All of these types of things will allow you to fine-tune the energy performance of your building and ultimately reduce your costs of operations. Renewable power, at this point I just would convey to you that if you're passionate about renewable energy, if you're passionate about solar energy in South Florida, definitely get involved or look into two different organizations, Floridians for Solar Choice and the Southern Alliance for Clean Energy. They seem to be spearheading the charge to make renewables more available, let's say, and to kind of decentralize. At this point in South Florida, it's really an effort to decentralize power. We've got one power company that is a very efficient machine for centralized power, keeps our power prices very low, and I don't want to say that it is reluctant to kind of release the reins on the private sector side of renewables. But these organizations seem to be spearheading that charge for decentralized power, and it's something that for sustainability in South Florida, it's absolutely a linchpin. If we ever want to get buildings off of the grid, if we ever want to get buildings to produce more energy than they use, we have to be able to feed it back into the grid, and we have to be able to come up with exciting economic scenarios that allow people to invest a lot of money in solar technology here locally.